for a long time it's been known you can bait Phytophthora. What we mean by baiting it is basically putting some kind of host material there where the Phytophthora, those spores are attracted to it, they exist on it, and infect it, and you can isolate it from that. The reason they do that is because it's actually kind of difficult to get Phytophthora out of soil any other way or out of water other way. And it also can be kind of out-competed by faster growing things, just putting out academia. This baiting technique is really very effective. As you saw, we're using these green pears. It turned out they're very good bait. They work for a wide variety of Phytophthora. Not necessarily every single one, or not equally well for every single one. So that's one of the things that we have to talk about testing. Okay, we're going to talk about this test. It is actually a very sensitive test. However, all tests can produce false negatives. So unless you do enough testing, you just end up with a false negative. And there's several things that can cause false negatives. But one of them is actually in commercial nurseries, a lot of times they treat materials with fungicides that are active against Phytophthora. They only suppress it, they don't actually kill it. Okay? So all these fungicides people think that making things go away, didn't go away, it just makes it harder to detect, actually. And once the fungicide concentration is very down, Phytophthora just goes like that to work where it was. So basically a single test on a single group of plants doesn't mean that that test that's clean. A single positive test, however, with the baiting technique, you don't really get false positives as long as you're not cross-contaminating your sample from some other sample. If you detect it there, it's there. If you detect it wrong, it's Phytophthora. Okay, so this is based off of living zoospores. Now, one thing about zoospores, they're little swimming spores, okay? And they have an interesting characteristic is that they swim upward. They have what's called negative geotaxis. They go swim in opposition to the force of gravity. This makes sense for them because they're trying to not get flushed down in the soil column down below the roots. They always want to work their way up or get up to the surface water. They can run along and associate somewhere else. Which means I'm trying to find out. Okay, now you see we've gotten a few bits of perlite out originally, and that makes sense because first there's a drain at the bottom, and some of those things that first filled up got into that drain. As it continues to pour out, you're not seeing any sand in here to speak of, and you're not seeing more perlite come out. So, and as long as I keep pouring this in here, and the outflow rate is sufficient, this will never overflow. Okay. So our pear is going to be floating right in the top of this material here. Pear, the whole time this is going on, floating up there right where all the zoospores are. And so the other thing that zoospores have the ability to do is be attracted to host material. So they can swim towards it. So they're swimming up, and if they detect that there's host material, there's some various little things leaching out of it, they swim towards it. And so that combination gives us a way to concentrate these zoospores around the bait and get them to a chance to infect it. So this is what we're going to be doing in the process of doing all this business down here. We're going to be irrigating these things with a certain specific amount of water, because one thing that happens with zoospores, they need to be flooded. Sporangia, which produce zoospores, have to be flooded for a certain period of time before they're going to release those zoospores. So we have to keep this irrigation going on for a while. But some stuff can flush out early. Some of these kind of thin sand-type particles here, the different infested materials can happen right at the beginning. There can be other things that flush out early. So the bottom line is we're going to irrigate these over a period of time to give a chance to flush these types of things out, including release of zoospores from the sporangia that would be on the roots of the plant. Okay, so that actually occurs over a period of 90 minutes. So we irrigate these things at 15-minute intervals 6 times. So the total volume of water that's applied across those tubing is approximately equal to the volume of the container. So we're basically putting a volume of water equal to the volume of the entire container through there over a 90-minute period. So watch these zoospores out and then see if they can be infected. So that's the basis of how this test works. Um, so the only other thing that you need to know about really is how we make sure we apply the right amount of water. Okay, so water is being applied such that this pot, you get that, essentially these are D40s is what they're called. And they get over the whole period, they get 110, 110 mils of water at each irrigation. Okay, 110 mils is that's 100 mil graduates, so a little bit more than that in each irrigation. Okay, so that this tells you that you have an issue here because you're not going to fit 110 mil very easily along the tops of these things. Those number ones will get 500 mils per irrigation. Okay, and so across the whole irrigation, those amounts will equal the volume of the pot roughly. So we do this by calibrating the flow rate of our irrigation device, which is these wands. And we use a kind of a fine valve here, a needle valve, that allows us to go from really low flows to fairly substantial flows. So the calibration can be a little bit dooky. But one thing about this, you've got this, you can see how much flow you've got out of the tip here. By making small adjustments, you can see it gets larger or smaller. Okay, we're going to have 110 on this new. Okay, so two things we're going here. We now got this calibrated. We also can take a look at the height of this water column, because that'll tell us that if this something is not, if the water pressure fluctuates, this is a lot higher or a lot lower, all of a sudden we know we got to reach that. Okay, so what you have to understand, the way a metronome works is that each tone is a time period apart. So if it's 1 second from this one to that one, okay? So this is not the second. The second is the time between click and the next click. So basically what you're going to, and the trick is, and this is where people have their little issues with, so you're going to basically irrigate, say we'll, why don't you try to do 2 at a time at most. So we're going to start on 1, and then we're going to count 1, 2, and then we're going to switch back at 1, okay? So if I'm irrigating, I'm going to go start at 1, 2, 1, 2, 1, 2, 1, 2. So I like to get everybody to see. Okay, so you can see, particularly, they have 2 types of D40s here. They have the expensive ones and the cheap ones. The cheap ones seem to have less head space in them overall. So those are the ones that are kind of sticking us. We could easily do 2 and maybe even go 3 if that's it. So we probably only 2 seconds each one. We're 26, so again. Always moving on 1, 2, 2, these are together, so they're doing a little around the corner.
I've already freshly sanitized my gloves with ethanol. So once they're dry, you don't want to do it while your glove is still wet with ethanol, but once it's dry, you can go ahead and get your bucket there. And you want to take out the pear, place it in. Now for the fun part, we can disconnect our slide, and it's time to drain the collection vessel. As I was explaining before, by draining from the bottom, we're concentrating spores at the top. So we can go ahead and start releasing the water. To the marked level.
Give me the marks on it. Oh, they have marks.
Yeah. Okay, so now we gotta drain it into this bag for incubation. One important thing to note is that when you're draining it, you can't drain it from this side. You'll start spilling out the spout. So from the opposite side of the spout there, get up. Make sure it doesn't fall.
You can also see he's not touching the bottom of the container just so he doesn't get that glove fully contaminated. That line.
Okay, so as before, we're gonna, with our clean hands, grab our pear, place into the bucket, remove our slide. Now, drain out. This looks like it's almost the right level. Almost. Okay. And
Are the bags going to be sealed?
So during the incubation period, you only seal them if you have to transport them. Yeah, but and so that's the whole point. So you can get the crud off the bottom into the thing. So if you're going to transport these, you would go ahead and seal it like you're going to transport. Try to keep a good air bubble in there so that you have some oxygen for those little things to use if they're in there, and keep it so it won't leave. So that's for transporting purposes like that. When we're going to incubate it, the bag will be left open.